Okay, this is where we are, lesson 1.2. By the end of the day, we're going to talk about how to multiply two matrices together, okay? So let's review first what we did when I saw you guys on Wednesday. We talked about the definition of a matrix. What's the definition of a matrix? It's a rectangular array of numbers. Okay, I only had to give you 5 words and you got it. You guys are there. I won't test you over definition. So your test won't be definition. This is just sort of trying to drill some things in. So a rectangular array of numbers. What does it mean to talk about the dimension of a matrix? What is that? Yeah, so that's the number of rows by the number of columns. It's the size of the matrix. Now, it was important. Maddie said rows, columns. Would have been just as correct if she had said columns, rows. Now, you might could argue, but it's confusing. Okay, so when we look at the dimension, we're always that first number is the number of rows, second number is the number of columns. Okay, we need to be consistent with that. What does it mean to add two matrices? Under what conditions can I add two matrices? They have the same dimension. And then go out on a limb, under what two conditions can I subtract? Same thing, they have to have the same dimension. What does it mean to have a scalar multiplication? What does scalar multiplication mean? Right, multiplication of a matrix by a single number. Scalar just means a number. It's just, math is just full of words, like we got 20 words that mean the same thing. So scalar multiplication means I'm multiplying a matrix by a number. If you multiply a matrix by 2, what in fact are you really doing? You're taking every number in the matrix and doing what? Multiplying by 2. That's all that is, okay? 3 times a matrix, every number in the matrix gets multiplied by 3. Now, but what we need to talk about today is how we multiply two matrices together, okay? So I've got this matrix A and matrix B, and I want to multiply those together, okay? What is the dimensions of A? A is a 2 by 2 matrix. What are the dimensions of B? 2 by 1. It has 2 rows and 1 column, okay? Now, we are able to multiply those matrices. Would we be able to add those matrices? No. Subtract? No. But we can multiply these matrices, and we'll talk a little bit more about why that works, okay? We can multiply these two matrices. Now, before we do the matrix multiplication, a lot of times when I hide something in a word problem, it makes it harder, but I think if I hide this in a word problem, it makes it a little bit easier. Suppose you have ice cream, okay? You have small cones and large cones. You have vanilla and chocolate, okay? And you have a price. The small cones are $1.25 and the large cones are $2.25. Now, before you even know what a matrix is, what is the math that I would need to do to figure out all the money comes from selling vanilla ice cream? What would I need to do? I would have to do 7 what? 7 times 125, all revenue from vanilla, and then plus what? Plus 13 times 225. If I did that on my calculator, that should come out to be $38, okay? So you would take, okay, look at vanilla and say, if I'm looking at vanilla and then I've got these prices right here, it would be 7 times 125 plus 13 times 225. Now, what if I wanted to figure out all the revenue that comes from chocolate? What would that be? 11 times 125 plus what? 14 times 225. And not to slow myself down, but I think I've got the answer. That is 45.25. Okay. So here's what we did. I've got a matrix here, 7, 13, 11, 14. This is the number of, this is vanilla, small cone, large cone. This is chocolate, small cone, large cone. These are the prices. So this is what you just did, was you multiplied this matrix times this matrix, okay? Using matrix language, what did we really do here? The number 7 came from where? using matrix words, rows, columns, things like that. It was what? This was from the first row, right? This was from the first row. So it looks like elements from the first row of this matrix were multiplied by the what? That's not a row, that's a column, okay? So the column of this. So it looks like to get this answer, it was this row, first row, and this first column. To get this one down here, it looks like I used the second row and the first column over there. So matrix multiplication is a row by column operation. So let's talk about how we're going to take it out of the context of ice cream cones, and we'll do that. So in order to perform matrix multiplication, you have to first figure out if it's defined or not, okay? So you'll look at the dimensions of the first matrix, the dimensions of the second matrix. If this is defined, these numbers have to be the same. So you just look at the inside numbers have to match. More precisely, the number of, this represents what? Number of rows or columns. The number of columns of this matrix has to match the number of rows of this one. That's too troublesome to remember. Just write the dimensions. If these two numbers are matched, you can do the multiplication. And then the size of the matrix you will end up with in your answer is going to be that, okay? So you end up with an M by P matrix. So the inside numbers tell you if it's defined. If those numbers don't match, what is the case? It's undefined, okay? And then the outside numbers tell you the dimension of the answer. So let's take a look and check and see what's defined and what's not defined. So what are the dimensions of A? It's 3 by 1. Somebody tried to trick me with it. 3 by 1, 3 rows, 1 column. What's this one? 2 by 2, that's the easy one. What's this one? 2 by 1, 3 by 3. If I want to multiply AB, so A is 3 by 1, B is 2 by 2, can I multiply these together? No, because these numbers do not match. So this is undefined. In matrix multiplication, this will be your favorite problem to get, undefined. Why is that? You're done, no arithmetic. Yes, Maddie? Which one? It's 3 rows and 3 columns. Yeah, okay. Let's look at BC. What are the dimensions of B? That's 2 by 2. The dimensions of C are what? 2 by 1. Can I multiply those two matrices? Yes, because these numbers match. I can multiply. What would the resulting answer be? 2 by 1, okay? So if the inside numbers match, your multiplication is defined. The size of your dimension, or the dimension of your answer, will be these outside dimensions. Matrix A is 3 by 1. What's matrix D? 3 by 3. Can I multiply A times D? No. So this one is undefined. Okay. Let's multiply D times A. D is 3 by 3. A is 3 by 1. Can I multiply those matrices? Yes, because these numbers match. The resulting answer will be a what? 3 by 1. Now this is interesting, or I'm hoping it is. You cannot multiply A times D, but you can multiply what? D times A. Now if these were numbers, you can multiply 2 times 3, and that's the same as 3 times 2. Doesn't matter, right? In matrices, it makes a difference. So the order makes a difference. You can't just switch things around with matrices. So in some cases like this, AD is undefined, but DA is defined. Okay, so that's one of the big differences between multiplying numbers and multiplying matrices. Let's look at the next one here. What are the dimensions of C? C is what, 2 by 1? And what are the dimensions of B? 2 by 2. Can I multiply CB? No, this is undefined. The dimensions of C are 2 by 1. The dimensions of D were what, 3 by 3? This is what? Undefined. Okay. And then the last one, I want to multiply D by itself. What are the dimensions of D? 3 by 3. Can I multiply 3 by 3 times a 3 by 3? Yes, the answer will be 3 by 3. Okay. So that's just an exercise of, before you do the multiplication, you have to determine if it's valid or not. So don't waste time trying to multiply things that will not multiply. So if the inside numbers match, then the operation is defined, and then the outside numbers tell you the dimensions of your answer. Okay. Now, where people mess up, it's always row by column. If you were to mix, and I know it's easy to do sometimes, if you were to call this matrix, I think we almost call this a 1 by, if you call this a 1 by 3, then you're going to run into problems. Okay, you have to get the dimension right in order to get the multiplication right. Let's do some multiplication then. So let's multiply matrix A times matrix B here. What are the dimensions of A? 2 by 2. Dimensions of B? 2 by 2. Dimensions of AB? 2 by 2. Okay, so because these inside numbers match, my operation is defined. My answer will be a 2 by 2 matrix. Okay, so this is probably a real common one that you're going to see. Now, I'm multiplying, this is matrix A, and that's matrix B, and I'm trying to get matrix AB. Now, what we talked about yesterday, I know that AB is 2 by 2 is going to have 4 numbers in it. What do these subscripts mean? The position. So this number is in the first row, first column. This number is in the first row, second column. Second row, first column, second row, second column. Now, that is helpful when you're starting out matrix multiplication, because that tells me what needs to be multiplied to get that number. Okay, so for example, I want to figure out this first number right here. Okay, what this tells me is I need to look at the first row of this matrix and the what? First column of this matrix. That's how I'm going to get the number that you see right there. So that's going to be 2 times -1 plus 1 times 5. That's the first number right there. Okay, I found that by looking at the first row of the first matrix and the first column and just multiplying the numbers. 2 times -1, 1 times 5. Okay, everyone see how I did that? The interactive portion of the class, teacher would say, and you would say, you got it. Okay. Okay, now let's move on. I want to find the number that goes right here. I need to look at what? The first row and what? Second column. So I need to be looking at this information. Okay. So in order to get that, that's going to be 2 times what? 4 plus 1 times 6. Okay, I'm halfway there. Now I want to move on to this number right here. In order to find that number, let me erase this. I need to look at what row? Yeah, second row, first column. So that's going to give me what? -1 times -1 plus 0 times 5. And then the next one is going to be what? Second row and second column. So that's going to be -1 times 4 plus 0 times 6. Okay. So everyone see how I did that? So this is a very important skill, because we're going to be multiplying matrices the rest of the unit. And if you're struggling with getting the right answers, you're going to struggle with making a good grade on this unit in multiplying matrices. Now, do you notice anything here? Like, look at these numbers. Do you see any patterns of what happened? What are the numbers in this row? 2 and 1? Oh, look, I see 2, 1, 2, 1. And then this row is -1, 0, -1, 0, -1, 0. And then look at this column. -1, -1, 5, 5. Look at this column, 4, 4, 6, 6. So you see patterns, okay? So like I said, what I find helpful is figure out the size of the matrix, figure out these subscripts to tell you what the locations are, and then use that to figure out what your answer is, okay? So you should be able to, I could give you a matrix multiplication that's real big, that's 6 by 6 by 6 by 6, but I wouldn't make you do the whole, I could ask you find one element, and you should be able to do that pretty straightforward, just by knowing which row and which column, okay? The biggest you're gonna have to do is 3 by 3 and a 3 by 3 by hand, okay? I'm not gonna give you a 4 by 4 or 5 by 5 and make you do all of that arithmetic, okay? So 3 by 3 is as hard as it's going to get for you. So now this is no longer algebra. What is it going to take to get to the final answer? It's not algebra, it's what? Starts with an A. Arithmetic, okay? So this is places where mistakes can be made though. This is -2 plus 5. What's that? The class said 3. This is 8 plus 6. 14. This is what? -1 plus, no, excuse me, +1 plus 0. It's 1. This is -4 plus 0. -4. Okay. The biggest danger in this is just making arithmetic mistakes. Okay. Pretty just straightforward. You guys with me? I know it's Friday. Wyatt, you need to stand up. Okay. I noticed I was putting you to sleep there for a minute. Yeah. Here I am putting you on the spot. Okay, guys, and I'll pause this. AB, let's multiply BA. So the dimensions of B are 2 by 2. Dimensions of A are 2 by 2. So because these numbers match, I can do the operation. My answer will be 2 by 2. Okay. So I need to find what element is in the first. I got to cross the first row with the first column, first row, second column, and so forth. So let's do first row, first column. Okay. I'll highlight it again, but then I'll probably stop highlighting after that. So first row with the first column. It might be helpful when you're starting out to circle it so you know which one you're working on. So the numbers are going to be what? -1 times 2 plus 4 times -1. Okay. Then I'm going to move on to find this number right here. I need to look at the first row with the second column. Okay. So that's going to be what? -1 times 1 plus 4 times 0. So those are half of the entries, okay? Now let's move down to this one right here. So that tells me what row of the first matrix? Second row, first column. So that's going to be what? 5 times 2 plus 6 times -1. And then the last one is second row, second column. So that's going to be 5 times 1 plus 6 times 0. And if you've done it right, -1, 4, -1, 4, 5, 6, 5, 6, 2, 2, -1, -1, 1, 1, 0, 0, those all line up. And now it just turns into arithmetic. So this is -2 plus -4. That's what? -6. -1 plus 0. -1. 10 minus 6. 4. And 5 plus 0 is 5. Okay. So I found that BA is equal to this, right? And AB is equal to this. So you see AB and BA are not the same thing, okay? So what do you observe about AB and BA? They are not equal to each other. So that's the difference. In numbers, you can always have, 2x is equal to x times 2. But with matrices, you cannot switch the order around. Okay? Let's look at another example. I got two matrices, A and B. First step is to write down the dimensions and determine if it's valid. So what are the dimensions of A? A is 3 by 2, B is 2 by 2. Because of those numbers matching, I can do the multiplication. What would the answer be? It's a 3 by 2 matrix. So the answer is going to be AB. It's going to have 3 rows and 2 columns. So that's what a matrix looks like that has 3 rows and 2 columns. Okay? How many numbers are there? 6 numbers. Okay, so to find AB, I have to find all 6 of these numbers. Okay, so how do I find this element? It's the first row of what? First row of A and first column of B. Okay, so that first number is going to be what? 0 times what? 0 times 1 plus 2 times -1. Now let's move over here. First row with the second column. So first row, second column, that's going to be 0 times 3 plus 2 times -5. That's the first row, okay? Now let's move to the second row. So I'm going to be looking at second row, first column. So that's going to be what? 6 times 1 minus 8 times -1. Now let's move over second row, second column. That's going to be 6 times 3 minus 8 times -5. Everybody with me? This is the time to let me know if not. I know it's Friday. So what do I have to do to find the last row? It's third row. So I start with third row, first column. So that's going to be what? 2 times 1 plus 4 times -1. And then that last element is third row, second column. So that's going to be 2 times 3 plus 4 times -5. Okay. So key to get all of this, and then if you need a calculator, have at it. You can always use arithmetic or 4-function calculator on anything in here. Okay. So let's do this. 0 minus 2, what number is that? -2. 0 minus 10, that's -10. 6 plus 8, 14. 21, no, excuse me, 18 plus 40. 18 plus 40. We'll go with 58. 2 minus 4, -2. 6 minus 20, -14. Okay, and that's our answer. Okay. So let's look at this one. What are the dimensions of A? Yeah, 1 row by 1 by 3, right? Okay. And did I skip one or did I? No, I did skip this. Sorry, let me back up. Let's find BA. Okay, in this problem we just did, what are the dimensions of B? What are the dimensions of A? So what about BA? Undefined. This is your favorite matrix multiplication problem to get. Undefined and you're done, okay? So there should be no arithmetic mistakes on this problem, okay? One of the things about teaching this class 3 times is like, by the time I got to this problem, I felt like something's missing. I've done this twice today. So anyway, hopefully you're getting the better version, but it's hard to say this late in the day. AB, what are the dimensions of A? 1 by 3, dimensions of B, 3 by 1. Can I multiply AB? Yes. So this tells me that they can be multiplied. What will the answer be? A 1 by 1. So this is, you're going to like this one because how many elements are in a 1 by 1 matrix? Yeah. I need to take the first row of matrix A with the first column of matrix B. So that's going to be what? 1 times negative 2 minus 1 times 4 plus 3 times 5. That's it. Okay, so you had one row of matrix A, one column of matrix B. So this is what? Negative 2 minus 4. What's negative 2 minus 4? Negative 6. What's negative 6 plus 15? 9. So your answer is not 9. Your answer is a 1 by 1 matrix, which only has one element in it, and that element happens to be the number 9. Okay, I will not make you explain that on a test. But so the answer is not 9. It's a matrix, and 9 is the only number that you see in that matrix. A couple more, and then we'll be done, and I'll turn you loose for the day. This one you should get very familiar with. It's probably the most common. This is a 2 by 2 and a 2 by 2. When you multiply 2 by 2 and a 2 by 2, you get what? A 2 by 2 matrix. Okay, so CD is going to be a 2 by 2 matrix. So those are the elements that are in that matrix. I use this because this helps me to figure out what row and what column. So this first number here is going to be row 1 of C, column 1 of D. So that's going to be 2 times 1 minus 3 times 3. Now the next element is the first row of C with the second column of D. So that's 2 times negative 4 minus 3 times negative 2. And then I move down here, second row of C, first column of D. So that's 1, 1, plus 5, 3. And then second row, second column. So that's going to be 1, negative 4, plus 5, negative 2. So this answer So what is 2 minus 9? Negative 7. Negative 8 plus 6. Negative 2. 1 plus 15. 16. Negative 4 minus 10. Negative 14. Okay. Let's multiply A times X. What are the dimensions of A? 3 by 3. Dimensions of X. 3 by 1. I can multiply AX. So AX will give me what kind of matrix? A 3 by 1. So I'm going to have first row, first column. Second row, first column. Third row, first column. That's what a 3 by 1 matrix would look like. Has 3 rows, 1 column. Okay. So to find this first element, it's going to be row 1 and column 1. So that's going to be what? 1x plus what? 2y plus 2z. Okay. Now I move to second row, first column. That's going to be what? 6x minus 8y plus 6z. Then I go to third row, first column. That's going to be 2x plus 4y plus 4z. Now, the reason we did this one is because what we're after in the next couple of lessons is starting with something like this and be able to extract this matrix to get a solution, okay? So that's what we're after. But what I did today was just let you multiply these two things together. But what we're after is getting to solve matrix equation, but I don't want to get too far ahead of ourselves. What you need to be grounded in today, you know how to add and subtract and multiply a matrix by a number. You need to get grounded in how you multiply matrices. You know, do you have to use color, markers, or do you have to circle the row and column? What helps you do that? That's what I need you to get grounded on to today.